Tyson has said that James Webb finally proved Stephen Hawking was right. It's been called one of our greatest minds of our generation, possibly of the century, and maybe ever. He's done groundbreaking work on black holes, relativity, and cosmology. Stephen Hawking was the proponent of a few controversial scientific theories, such as his multiverse theory or his ideas about what dark matter really is. But he never lived to see his theories proved or disproved, as he passed away before humanity could upgrade its scientific tools. Thanks to the James Webb Space Telescope, we can finally test one of Stephen Hawking's theories. Join us as we explore the depths of dark matter and find out if Stephen Hawking was right all along. Dark matter research indicates that the dark matter theory. The James Webb Space Telescope holds the potential to validate one of Stephen Hawking's most debated theories, his dark matter theory. Back in 1970, Hawking proposed a contentious idea suggesting that dark matter, the unseen substance dominating the cosmos, might consist of black holes that emerged during the early moments of the Big Bang. 3 astronomers in 2021 built upon Stephen Hawking's concept and developed an intriguing theory that could not only explain the existence of dark matter but also shed light on the existence of supermassive black holes in our universe. We could finally get the data we needed for so long, all thanks to the development of new instruments like the JWST. For Priyamvardhan Natrojan, co-author of the study and an astrophysicist at Yale University, this theory presents an exhilarating convergence of 2 complex challenges. She works on exploring the nature of dark matter and understanding the formation and growth of black holes. The new idea elegantly resolves these puzzles simultaneously. Excitingly, the JWST, among other innovative instruments, has the capacity to collect data critical to scrutinizing Hawking's famous notion. Dark matter accounts for about 27% of all matter in the universe, but finding it isn't easy. It does not directly interact with light, but its immense mass affects the gravity within galaxies, making it an elusive cosmic enigma. The prevailing theory in the modern scientific realm is that dark matter is made up of an undiscovered subatomic particle, suggesting that a new particle has to be introduced to explain this mystery. However, Stephen Hawking presented a theory that relied on already discovered phenomena, like black holes. The notion that black holes might be the key to the existence of dark matter does have a tantalizing appeal. They do have a reputation for absorbing all light, and a galaxy filled with black holes seems like a plausible explanation for the mysterious dark matter that has amazed astronomers for so long. Could these black holes be the answer to the dark matter puzzle? Without this dark matter, our understanding of the universe's existence would crumble. Regrettably, the formation of black holes in the universe relies on the demise of massive stars, which collapse under the pull of their own gravity. Consequently, generating black holes demands numerous stars, which in turn requires a substantial amount of normal matter. Scientists have calculated the amount of normal matter present in the universe based on the early universe's primordial hydrogen and helium formation. The problem lies in the observation that there isn't enough normal matter to account for all the dark matter that astronomers have detected. In 1971, Hawking presented the idea that black holes might have formed during the chaotic birth of the universe in its earliest moments, creating pockets of matter with the necessary density to give rise to black holes. Because of this, the universe could have been flooded with these primordial black holes long before the first stars formed. Hawking proposed that these primordial black holes might be the elusive dark matter's missing pieces. This theory of primordial black holes was eventually abandoned in favor of the prevailing belief that black holes originate from the collapse of massive stars at the end of their life cycles. While Hawking's theory was interesting, most astrophysicists shifted their attention toward different explanations, like the presence of a new subatomic particle that could explain dark matter. Also, the models of primordial black hole formation faced observational challenges. If an excessive number of these black holes emerged in the early universe, they would significantly alter the radiation left over from that era, known as the cosmic microwave background, CMB. This discrepancy meant that the theory was viable only when the count and size of ancient black holes remained relatively limited, as it had to harmonize with measurements of the CMB. But this theory would be revived decades later, all thanks to advancements in technology like the Laser Interferometer Gravitational Wave Observatory, LIGO. Back in 2015, LIGO discovered its first pair of colliding black holes. Turns out, black holes don't always meet our expectations. When we finally get a better look at them, some seem shockingly huge while others appear quite little, challenging the popular notion that they all originate entirely from the implosion of giant stars. The ones that LIGO detected were massive, which raised the possibility that they formed in the early universe rather than from the fading embers of stars, causing scientists to consider Hawking's theory once again. Black holes of varying sizes continue to baffle scientists. They struggle to comprehend how supermassive black holes could have attained such immense sizes in the relatively brief period since the universe's inception, and that's why the three astronomers decided to take a deeper look into this theory in 2021 to find out more about primordial black holes and their potential to explain dark matter and other space mysteries. Hawking's revised theory: to meet the current observational criteria, primordial black holes must lie within a specific mass range. In their investigation, the scientists theorized that these black holes would have a mass of approximately 1.4 times that of our Sun. In black hole terms, this is quite light. They devised a model of the universe, replacing all dark matter with these relatively lightweight black holes, and proceeded to review any observational evidence that could either validate or dismiss their model. The new model put forth by the researchers altered certain aspects of the presumed timeline of the universe's evolution. If primordial black holes have existed since the inception of time, they would undergo accelerated merging, affording ample time to grow to sizes detectable today. The research team found strong proof that primordial black holes could have played a major role in the early universe by seeding the first stars, galaxies, and supermassive black holes, especially when you consider the fact that these stars and galaxies emerged too quickly in the cosmic timeline. Typical formation and growth processes that are observed in the present-day universe cannot explain the existence of such large celestial phenomena. When the universe was roughly 370,000 years old, it was filled with gas clouds and dust. Light could travel long distances freely, but there was nothing that could produce light. These were known as the Dark Ages. This period would last hundreds of millions of years, but the existence of primordial black holes could have sped up the formation of the first few stars and galaxies in this period. This would be due to their gravitational forces causing dust and gas to collapse faster than the predicted timeline, consequently ending the mysterious Dark Ages earlier, as well as light-producing celestial bodies like stars emerging much earlier. Primordial black holes, if proven to exist, could serve as the precursors for all supermassive black holes, including the one residing at the heart of the Milky Way. Moreover, it's not just the massive black holes that pose a challenge to explain. ESA's Gaia mission, responsible for the most detailed three-dimensional mapping of the Milky Way, has unveiled evidence of numerous smaller black holes scattered across the galaxy. These black holes are too small to have formed through the demise of colossal stars. The researchers say that the beauty of this theory lies in its simplicity. It does away with the need for a multitude of new particles to account for dark matter when it can be simply explained by primordial black holes. This idea is currently just a model, but the researchers claim that it holds the promise of testing. JWST, tailor-made to investigate the origins of stars and galaxies, stands poised to answer crucial questions. JWST's mission is to detect the first light that illuminated the universe, coming from the very first stars after the Big Bang. Figuring out precisely when this occurred will determine the validity of two competing theories, whether black holes existed from the universe's inception or formed only after the first generation of stars perished. If the first stars and galaxies indeed took shape during the Dark Ages, the JWST should yield evidence to validate this claim. Furthermore, the next generation of wave detectors shows promise in discovering more about black holes, such as the Laser Interferometer Space Antenna, LISA. We might even find evidence of primordial black holes. With the combined power of LISA and James Webb, astronomers may finally piece together the saga of the first stars and perhaps the genesis of dark matter. This research was presented in late 2021, shortly before the JWST's launch, heightening anticipation for the telescopic mission's monumental discoveries. Latest dark matter discovery. So, what has the JWST discovered so far in terms of dark matter? 68% of the universe's energy matter content is composed of dark energy, while roughly 27% is dark matter. Astonishingly, the galaxies, stars, and planets that compose the observable universe amount to merely 5% of its entirety, while 95% of the universe is just dark energy and dark matter, which remains a complete enigma to us. But in the scientific community, it's believed that the mystery of dark matter will be solved by particle physicists and not due to a miraculous discovery by the JWST. Although the JWST won't directly uncover the true identity of dark matter, its observations of how dark matter interacts with galaxies can provide crucial information that may contribute to solving the long-standing puzzle. Dark matter has been identified via the gravitational effects it exerts on regular matter. Gravitational lensing occurs when light from distant objects bends around massive celestial structures, providing a means to detect dark matter. The James Webb Space Telescope can peer deep into the universe and survey the light from ancient galaxies while capturing the light distorted by dark matter's influence. By gathering high-resolution images of these distant objects, astronomers can measure how gravity from dark matter distorts light from far-off galaxies, providing insights into dark matter's behavior. In 2023, a series of galaxies in the early universe were examined, and the data revealed that dark matter formed within galaxies, emitting infrared light, which is visible in the JWST's findings. As the researchers stated, the existing information could potentially unveil how galaxies were shaped, when they originated, and how dark matter interacted with them. Future discoveries await. If Hawking's theory of primordial black holes turns out to be accurate, the James Webb Space Telescope could be the key that allows us to look into the distant past and reveal what dark matter truly is. The James Webb Space Telescope stands as a testament to human ingenuity, with its groundbreaking discoveries promising to alter our understanding of the cosmos forever. As scientists delve deeper into this cosmic enigma, they are set to uncover more secrets hidden within the universe and confirm whether Stephen Hawking was indeed right all along.